Hello, welcome back. I am Rajendra Bade, and in this video we'll continue with sectional orthographic views. Today we are going to solve a problem asked in Mumbai University December 19 question paper. Let's proceed. Read the problem. Following figure shows pictorial view of an object. Draw sectional front view along section AA. Watch the diagram. Section AA, here it is, letter A printed, and here it is. Now try to understand from this dark dash to this dark dash. This is that section line or cutting line. This line is in the cutting plane. This cutting line cuts object in two parts, the portion on the front side and portion on the back side. But try to understand the question. You are asked to draw sectional front view along section AA, but not sectional top view or sectional side view. You are asked to draw top view, left hand side view. So we draw complete top view, complete side view, and front view is sectional. Now here object will cut into parts, portion on the front side and portion on the back side. The portion which is closer to observer, that is portion on the front side, is imagined to be removed. Now as usual, first we'll have to check overall dimension. Length is 122. How come? Let's check. Extreme left end is curved edge. What is radius of the curved edge? Diameter of that circle is given 44, so radius is 22. So 22, we are identifying length of the object. So parallel to length axis, check all dimensions. So it is 22 plus 100. So 22 here plus 100. So from extreme left end to extreme right end, the length is 122. Now what about width of the object or height of the object? So 64 from top end of the object up to this plate, it is 64. So of course we'll have to add thickness of the plate. So 64 plus 22, but be very careful. You check all vertical dimensions. Here it is 10 millimeters given. Below the plate, cylinder is extended slightly. How much is that extension? 10 millimeter. So total height is 64 plus 20 plus 10, 94. So this is that total height of the object. Now check width of the object. All dimensions parallel to width. So check here 15 millimeters plus 35 millimeters. That is 50. 15 plus 35, 50, 50. And then thickness of this plate 10 millimeter. So 50 plus 35 plus 10, that is 60 millimeters. But then it is symmetrical object. All visible features on front side, remember this arrow suggests you front side. Visible features on front side and back side are similar. So that suggests you that the front side and back side are identical. So 50 millimeters on front side. So similarly, there is 50 millimeter distance from this plate on the back side also. So total width is 50 plus 10 plus 50 on the back side. So it is 110. So width of the object is 110. So now I need not tell you why this orientation is width orientation, because I have explained you in my many earlier videos. Parallel to this arrow suggesting front side, it's also that is width axis. So this is how we have identified overall dimensions of the object. Now we'll proceed. Remember what we are going to draw? Sectional front view and top view and side view, and that is left side view. It is first angle method of projection. So left hand side view to be drawn on the right side of front view. So when you draw at initial stages the three rectangles for front view, for top view and for left side view, be careful that there must be enough space on the right side of front view. And we should start with the front view rectangle, that is take care of length axis and height axis. Okay. Now side view of complete object, top view of complete object, and check here. The object is getting cut by cutting line A. So on the surface of this object, there is a cut. You can clearly see. So now this cutting line AA or vertical plane containing this line has made two parts of this object. front portion and back portion. So front portion is to be removed. Portion nearer to observer is to be removed so that inner details are revealed. So this hole is getting cut. The semicircular slot is getting cut. And where material gets cut, solid portion gets cut, you get a new surface. Here with grey color, I have highlighted that. That is newly generated surface. In our sectional orthographic view, that is sectional front view, it will be hatched surface. Okay. So we are going to draw front view of this portion. Remember, that is sectional front view. But top view and side view, complete views. Now let's start drawing rectangle. Length is 122, height is 94. Which two dimensions you get in the front view? Yes, length horizontally and height vertically. So measure height 94, length 122 and complete the rectangle. Now since we have measured length already 122 in the top view, we need not measure length 122 again. In fact, you must not. You should project that length 122 millimeters in the top view. Which two dimensions you get in the top view? Correct. Length horizontally and width vertically. But when you draw that rectangle in the top view, there must be enough space between front view and top view. So leave about 20 mm space. Then measure 122 millimeters, width 110 mm and complete the rectangle for top view. Now we are asked to draw left side view. That is why we have enough space on the right side of front view. Which two dimensions you get in the side view? Height, vertical, and horizontal dimension is width. Now since we have already measured width 110 mm here in the top view, we must not measure the width independently in the side view. Instead, we should transfer width in the side view. So let's do that. So 45 degrees line to transfer width from top view to side view. In the top view width is vertical, in the side view width is horizontal. Let's proceed. So I have transferred height 94 mm in the side view by drawing end projectors, and then we'll draw end projectors from top view. And this is how we have transferred width. Now here in the side view, width is horizontal and complete the rectangular box. So front view, top view and side view. Okay. Now is this object symmetrical object? Yes, its front side and back side are identical, or in fact mirror images. So front and back similar. In which views you can identify or separate front side and back side? In the top view and in the side view. Don't forget that this is front side and this is back side. So front side portion and back side portion are similar or mirror images. So there must be mirror line, that is axis of symmetry here. Measure 55, total width is 110. Measure 55, half of 110 and draw that axis of symmetry, center line for the top view. And same way here, this is front side and this is back side. In very first video on orthographic projection, I have explained that this is front, this is back, it is top and bottom. Had it been top bottom similar, we would have drawn center line in this manner, but here it is front and back are same, so we should draw axis of symmetry here, or you may simply project that axis of symmetry in the side view. So this is how this axis of symmetry in the side view have made two identical parts, front side and back side. Okay, so we have completed with axis of symmetry. This is our standard regular procedure. Now let's continue. Now watch this diagram. Clearly we can identify four parts or portions of the object. This is a cylinder. It has a concentric hole. Here it is semi-cylinder. It has semi-cylindrical slot. Here it is a plate, horizontal plate, which has two holes of diameter 15 each, and trapezoidal plate, that is a rib. It connects major parts of the object. That is a rib, a thin plate of thickness 10 mm. So four parts we have identified: a cylinder, semi-cylinder, a horizontal plate of thickness 20 mm, and a rib, a plate connecting three major parts to increase strength of the object. Okay. Now major parts which we'll draw first. Shape and remaining to views rectangles. That is our regular procedure when you can identify portions of the object. Okay, so we'll start with the cylinder. So 22 millimeters. From left side, to draw this circle, cylinder, it is a vertical cylinder. In the top view, it appears circle. So to draw the circle, we should establish its center. Top view symmetrical. So center is on axis of symmetry. And from left side at distance 22 millimeters. So I have measured 22 millimeters and this is the center line. So we have established the center. Now draw circle of radius 22 millimeters. So that diameter will be 44 millimeters. So this is how we have completed the circle. Now the cylinder has a hole. Smaller details we'll prefer drawing afterwards. So let's draw major parts. So cylinder in the top view, remaining to views rectangle. Which two dimensions you get in the top view? Width horizontally, which we have transferred in the length horizontally, which we have transferred in the front view. And height. Now what is height of the cylinder? 40 millimeters. So measure 40 millimeters and complete the rectangle. So cylinder is complete in the front view. Similarly, draw cylinder in the side view. So these are the projectors. In the top view, the width is vertical and same width should be in the horizontal. That's why we draw projectors. Remember, I have told you many times earlier, it's not necessary to draw projectors from each and every portion, each and every details. So you may avoid drawing these projectors. Instead, we know that this vertical dimension of the circle is nothing but the diameter 44. And that 44 diameters will appear here. So you measure 22 and 22 here independently instead of drawing these projectors. In fact, I prefer measuring independently. Once again, when you draw three rectangular boxes, don't forget that side view box is to be drawn by drawing projectors only. By drawing end projectors. You need not measure it independently. But remember, for smaller portions, it's your choice. For smaller portions, you may measure independently in each views. Okay. So this is how, by drawing end projectors, I have completed rectangular box in the side view also. Now where cylinder appears a rectangle, you must not forget to draw axis. Here already that center line is present in the side view. Here in the side view already the center line is present. In the front you will have to draw that center line. Okay. So remember once again, we'll draw that smaller detail, that is the hole, later. Let's proceed for that semi-cylinder. It has semicircular slot. Right now don't worry about slot. First the semi-cylinder, then we'll make the slot. So like this cylinder we are drawing, semi-cylinder also, slot will draw later. So let's draw the semi-cylinder first. In top view, semicircle, remaining to views rectangle. It's that simple. So look at the center, it is extreme right on axis of symmetry. So here it is the center. So use that center. What is that radius? Radius is 32. Watch it. Radius of this outer semicircle is 32. So take that radius and draw the semicircle. So this is how we have completed the semi-cylinder. So this is semi-cylinder. There is a slot of course, but unnecessarily don't get confused. We are going to draw that slot later. Okay. So semi-cylinder, project, draw end projectors. Horizontal dimension is the length of the semi-cylinder in this view. And that length appears horizontal again in the front view. And what is height of the cylinder? 64. From top, you should measure 64 and complete. So we have measured 64 from top and this rectangle is the semi-cylinder. In top view semicircle, in front view semi-cylinder is rectangle. And in the side view also, height 64. In the side view you get height vertically. That's why we draw end projectors for the semi-cylinder. And from top view, vertical dimension in the top view is width of this part. So that width becomes horizontal in the side view. So horizontal projectors from front view to side view and vertical projectors from top view to side view. And this is how we able to draw rectangle in the side view. Remember, it is semi-cylinder in the top view, semi-cylinder in the front view, and semi-cylinder in the side view. Okay, now very, very important part. Focus here on your screen. This is top view of semi-cylinder. This is top view of cylinder. Okay, they are not even in contact right now. Okay, here front view of semi-cylinder and front view of cylinder. But in the side view, this is top view of cylinder and this is this is side view of the cylinder and this is side view of semi-cylinder, and there is overlap. Have you noticed? Side views of these portions are overlapping, and that is why we'll have to check which portion is nearer to the observer. Where is observer? So this is side view and it is left side view. So observer is watching from left side. So cylinder is nearer to the observer. So semi-cylinder's overlap portion, which is exactly behind the cylinder, is hidden, and that is why the overlapped portion of semi-cylinder, here it is, this portion, you should draw hidden. Have you understood that? No intelligence is required to understand. If views of two portions overlap, then check out of those two portions which portion is nearer to observer. That portion is completely visible and the overlap portion of the other part is hidden. So this is hidden, simple. Okay. Now let's proceed for the third part. That is this plate. Remember, this plate has two holes. Like cylinder and semi-cylinder, these two holes will draw later. First, major parts. There will be plate first and then we should make the holes in the plate. Okay, so let's draw this plate. So in the top view, its largest surface is visible. Correct? This surface is visible in the top view. How to draw that shape of that surface? First curved edges, then principal edges, and then non-principal edges. This is how we should proceed. Okay, so now watch here, this edge, and similar edge is on the back side. This edge, it is parallel to width axis. Watch here, this is width axis. So parallel to width axis. Width appears vertical in the top view. So we should draw this edge and corresponding edge on the back side vertically here. This is front side and this is back side. So let's draw those edges here. Focus. Here it is edge and this is that edge. So these two edges we have completed. Now we'll draw these two edges which are parallel to length axis, width and length. Width vertically, length horizontally. These are the two dimensions you can see in the top view. And now we are drawing principal edges. So 66 millimeter, that is length of these edges which are parallel to length axis. So measure 66 millimeters here. Watch and draw. So this is how we have drawn those principal edges, and then non-principal edges which are tangential to the cylindrical surface. So here is the cylindrical surface that appears circle in the top view. So simply draw tangents. So manage two tangents from ends of these two principal edges, and this is how that plate is complete in the top view. Remaining two views are rectangle, simple. So from end projector. So watch here, this is the shape of the plate in the top. Boundary of that surface I am showing you. This is that. Okay. So end projectors of this plate from top view to front view. So let's draw end projectors. Check here. Here that plate ends extreme left corner of this plate, where it becomes tangential to the cylinder. Okay. So I've drawn the projector and here I've drawn projector. Check these two red colored lines. Okay. So that means length we have transferred. And what is height of the cylinder? 20 millimeters. So that height 20 millimeters to be measured by leaving 10 millimeters from base. So leave 10 millimeters from base and then measure 20 millimeters. And this is how that plate is complete. Okay. So this is the plate in the front view. Okay. Now this shape has sharp corners here. Watch here, this corner. And the corner is formed by three edges. So clearly in our isometric view, that is this pictorial view or three-dimensional view, you can see this edge which is vertical, parallel to height. So from this corner, draw the projector and draw the edge. So this plate we have completed here. Now remember, in front view, this is semi-cylinder, here it is cylinder, and this is plate. So we'll have to take care of joints where these portions meet, take care, or surfaces meet. Okay, so this is semi-cylindrical surface, watch here. And this is that horizontal, vertical strip-like surface. Here it is. Horizontal strip it is, but it is vertical surface. These two are different surfaces. So of course, when there are two surfaces, independent surfaces, then there should be a dark edge here. Okay. Now we'll check this contact. Remember now, this is very important to understand. And I've told you in earlier orthographic views videos also. One thing I want to tell you, if you want to get benefited by this video, I recommend that you should watch my earlier videos on orthographic views. There are 5 videos on orthographic views and 1 video already I've made on sectional orthographic view. And this is second sectional orthographic view video. Okay. Now I've told you earlier that when there is joint on end generator of a cylinder, when you get joint directly on end generator of a cylinder in a view, that end generator is to be erased inside the joint because that is not at all there. So this is how I've removed it. Now also watch this three-dimensional diagram. This inclined surface meets tangentially to the curved surface. So this edge also you should not draw. Okay. Then if an edge meets tangentially to the curved surface, you should use that notation to suggest tangential joint. You know that at end of this edge, a small curve here and a small curve here. I'm not drawing here right now because we are going to draw sectional view. Okay. Now sectional front view we want to draw, not sectional side view. Now check carefully. This vertical edge we should remove. First rule in sectional orthographic views. Portion nearer to observer is imagined removed. So we are removing this portion. So this edge will get removed. When we remove the portion nearer to observer, this edge will get removed, and that's why this edge will not appear here. So corresponding to this corner, the edge which is nearer to observer is now to be removed because portion nearer to observer is imagined removed. But identical edge is on the back side. From this corner also there is vertical edge. Like this vertical edge on the back side from the corner there is vertical edge. So that is hidden edge. Second rule in sectional orthographic views. No hidden details are required in sectional views. So we are not going to draw that hidden vertical edge here. Okay. Now this line I have erased. And this line here the two lines I have erased. I have removed simply those lines. Remember, when two portions, this plate here and this semi-cylinder, when two portions get cut by a cutting plane, boundary between the two portions separating the surface of the two portions to be erased. Check here, this is semi-cylinder and this is plate. This is surface of semi-cylinder here and this is surface of the base plate. Boundary between the two now will not appear here. The reason is this portion is removed and now what we are watching here is a one single plane, and that is cutting plane, surface in cutting plane. Similarly, here the two lines separating cylinder and the plate have erased. So now this is the section. But smaller details we have not yet drawn. Okay, let's proceed. This plate I'll complete in the side view. This plate I'll complete in the side view. The plate of 20 mm height will draw in the side view. So in the side view also, as usual, a rectangle. Which two dimensions you get in the side view? Height vertically and width horizontally. So height, draw end projectors suggesting height of this plate. Check here, I've cut the object. Can you see this surface? This surface is in one plane. The corner here on the back side, similar corner was there on the front side, which we have removed. That is why corresponding to this corner, dark edge is removed, and on the back side there is hidden edge, not to be shown in sectional view. We are drawing orthographic sectional front view. Okay. Now smaller details we are going to draw. Height I have transferred in the side view for rectangular plate. Its width I have transferred here. Width of this plate. This is width of the plate. I have drawn in projector. And this is the rectangle. Watch, can you see clearly a rectangle here? Yes, this is that 20 millimeter high or 20 millimeter thick plate. Okay. Now, no rocket science or no much intelligence is required to understand these two dotted lines. Remember, this plate is, when observer is watching from left side, it is behind the cylinder. So this is what I've told you in the same video little earlier. Listen again. This is side view of the horizontal plate, and this rectangle is side view of cylinder. There is overlap. So as usual, I checked here. This portion, cylinder, is nearer to the observer. So cylinder is visible and overlapped portion of this horizontal plate is hidden. So the portion of the horizontal plate which is hidden here, I am shown by dotted lines. If I ask you where is that horizontal plate in the side view, show me this entire rectangle. Simple. But now you will have to think about the joints. Now, where this plate meets curved surface here, it is tangential joint that is to be shown here. So from those points I have drawn the projector. Watch here. This edge meets curved surface. In the top you check. This edge meets curved surface tangentially. From those 2 points on the front side and on the back side. From those 2 points I have drawn projectors. So now these edges, what in pictorial view, these edges, one on the back side, one on the front side, these 2 edges here will show. So these 2 lines from these corners, these 2 lines, we should extend up to the projector. So check here, extend it here, extend it here. Similarly on this side, focus here. I have extended up to the projector. And then by drawing those small curves at end of these extensions to indicate tangential joint. Check. So this is how we indicate the tangential joint. Now one more thing here. When there is a joint on end generators of a cylinder, end generator inside the joint does not appear. Okay. So watch. So this is how left side view is complete. For this plate, of course. Now let's draw smaller detail. This is that cut object. Remember what I told you? Some hidden details get exposed. So there's vertical hole in the cylinder and semicircular slot in the semi-cylinder. They get exposed. How will you come to know? Cylinder and semi-cylinder. This hole in the cylinder and a semicircular slot in semi-cylinder. They are getting cut by the cutting line. That means this hole in the cylinder and semicircular slot in the semi-cylinder are exposed. That means their inner surfaces are exposed. But what about these holes, these 2 holes? There is a hole on the back side in horizontal plate. Similarly, there was hole on the front side. These 2 holes are not getting cut. So rule in sections of solids. Remember, some hidden details get exposed because of cutting. Those hidden details in sectional views will be visible. Some hidden details remain hidden even after cutting. Those hidden details we need not draw in sectional view. Remember, no hidden lines in sectional views. Let's proceed. Hole in the cylinder. Its diameter is given 22 millimeters, so radius 11 millimeters. Draw circle. It is concentric hole. So this is opening of the hole in the top view. Draw in projectors. And now, had it been a complete front view, we would have drawn hidden lines. But since it is sectional front view, we should make that hole visible. Is this hole getting cut by the cutting line? Yes, this is cutting line AA. It is passing through center of the hole. Okay. Now same hole in the side view. As usual, I have projected it. diameter is 22 millimeters. So you can measure here 11 millimeters and 11 millimeters independently instead of drawing these projectors. And then dotted lines. So hole is of course hidden from left side. Okay, so hole is hidden. So hole we have completed in all the three views. Now there is semicircular slot in the semi-cylinder. Let's draw it. 18 millimeter radius, and I have made the semicircular slot. Now slot has no closed boundary, so this portion of the dark edge I have erased or trimmed. So this is semicircular slot. Projected. When depth of a slot or a hole not given, it is to be assumed through hole. It should have opening on the other side. So this semicircular slot from top to bottom we are going to show. Watch here. And slot is getting cut. Had it been a full view, full front view, we would have drawn the slot hidden from front. But because of the cutting, inner surface of the slot is visible now. Now let's draw this semicircular slot in the side view. Now from left side, this slot is of course hidden because the slot is extreme right side. So draw end projectors from front, that is entire height of the slot. And from top, draw end projectors of the slot. And this is how that slot is. Check. These dotted lines are up to the end projectors here. This slot we have shown not just in the semi-cylinder, but in the horizontal plate also. So that is why these dotted lines is up to this horizontal. Check. Okay. So this is how we have completed that semicircular slot in all the three views. Now horizontal plate, there are two holes. Let's proceed for the two holes. So check all dimensions. 44 millimeters given and 15 millimeter from the edges parallel to length. So we have located the center. And here also. So this is how we have completed the holes. Alright. Now these two holes in the front view. But try to understand. Portion nearer to observer is imagined removed. And this hole is still there. Once you remove this portion, there is a hole here. But simple logic to draw sectional view. Tell me whether these two holes are getting cut by the cutting line. This is the cutting. And these two holes are not getting cut by cutting line here. Check here. Passing through the center of cylinder and center of the semicircle. This is the cutting line. So cutting line is not cutting these two holes. So we simply must not draw those two holes here. So we are not going to draw these two holes in the front view. But draw axis of the holes to suggest presence of these two holes here. Okay. So this is how these two holes in the front view. Remember, no hidden lines in the front view. Some hidden details get exposed. So this hole and the semi-cylindrical slot. Make them visible. Some hidden details remain hidden even after cutting. You simply don't draw those hidden details. Okay. Now let's draw these two holes in the side view. Check. And from this hole also. And draw down. Now where hole appears a rectangle, circular hole appears a rectangle, center lines. That is nothing but axis of the hole. Here also this line is nothing but axis of the hole. So this is how we have completed holes, these two holes in all the three views. Now one more small portion, that is this rib. This rib is 10 millimeter thick rib. It is after all plate. In a view shape, remaining two views, just thin strips of thickness 10 millimeter we are going to draw. In which view its shape is visible? In the front view. So let's draw that. This plate is in contact with semi-cylinder. It is also in this. It is also in contact with the cylinder here. It is also in contact with the base plate here. So only that non-principal edge now to be drawn to complete that shape. So this is how we have completed that plate in the front view. Now draw end projectors. This is length of the trapezoidal plate. And draw the strip between semi-cylinder and cylinder. Thickness is 10 millimeter to be measured 5 millimeters. Above the center line 5 millimeters, below the center line, so that you will get total thickness 10 millimeter. Top view is symmetrical, so of course this strip you are going to draw symmetrically. That is why you measure 5 millimeters and 5 millimeters. Okay. Now end projectors, and this is very important where many students make mistakes. Okay. So extreme top of trapezoidal plate, extreme bottom of trapezoidal plate, bottom of trapezoidal plate, top to bottom, that is height. So here it is width 10 millimeter I have projected, here it is height I have projected. So height vertically in the side view, width horizontally in the side view, and here now we are going to draw that strip 10 millimeter width, and that strip is in between these two projectors, because whatever height of the trapezoidal plate in the front view, of course the same height will appear here. That is why we have drawn these two red colored projectors. Okay, so this is how I have completed. Immediately you will realize that I am making mistake here. Do you know what is that? Two visible edges don't intersect. So correction. And what is that? Try to understand. Logic is the same which we have discussed earlier. Here is cylinder, and this strip is the trapezoidal plate. Side view of cylinder and side view of this trapezoidal plate, they overlap. That is why I am checking here. Cylinder is nearer to the observer, and behind cylinder some portion of this plate that is hidden. So overlapped portion. Now on your screen, focus in this portion where that red dot is. Focus here. Portion which is overlapped, portion of the plate, that thin strip which is overlapped, I am making it hidden. Check it. This portion I have seen many students, they forget to draw. Okay, so this is how trapezoidal plate also completed in all the three views. In short, we have completed side view and top view, complete side view and top view, and sectional front view. The newly generated surface, this rectangular surface here where right now a red dot is, and this surface, that is hatched portion. This is hatched portion and this is hatched portion. Hatched portion means newly generated surface where we draw hatching lines. Now once again to remind you, this is inner surface of the hole. We should draw hatching lines only on newly generated surface due to cutting. Inner surface of the hole is not surface generated due to the cutting. So in this portion, this rectangle, what is this rectangle? Inner surface of the hole. We must not draw hatching lines here. This rectangle here, this rectangle, this is inner surface of semicircular slot. We must not draw hatching lines here. So cylinder is getting cut, so solid portion of the cylinder, here you are going to draw hatching lines, here you are going to draw hatching lines. Plate is getting cut, semi-cylinder is getting cut, so here you are going to draw hatching lines. Now what about this trapezoidal portion? So as I told you, that when largest portion of a plate, I have told you earlier in earlier video, when largest portion of a plate appears in sectional view, then you should assume that plate as uncut plate. Watch now this three-dimensional diagram. Cylinder is getting cut, semi-cylinder is getting cut. Likewise, this trapezoidal plate is also getting cut. Thickness of the trapezoidal plate is 10 millimeters, and trapezoidal plate also getting cut, so its thickness has reduced now. So this trapezoidal surface now you are watching is the newly generated surface, and like this shaded surface in this pictorial view, focus on that red dot. Like this shaded surface, this trapezoidal surface is also newly generated surface, and it is in the same plane, that is plane of the cutting plane. So there must not be these edges indicating boundary of that trapezium. When two portions get cut by a cutting plane, boundary between the two shapes you should erase. Just say for example, cylinder and horizontal plate, boundary here we have erased in sectional orthographic. So whether we should erase these boundaries? So no, as I told you, ribs, that is those plates with largest surface in sectional view, are to be assumed uncut. So we should assume that this plate is not cut. That means we must not draw hatching lines here. So one more rule on sectional views. If largest surface of a plate appears in sectional view, then don't draw hatching lines on that surface. So here on this trapezoidal surface, we are not going to draw hatching lines. So let's show the hatching lines. Watch here. 45 degrees inclined line, faint lines. So simply the newly generated surface we have shown by hatching lines, and original surfaces we have not shown by hatching lines. So inner surface of the hole, inner surface of semi-cylindrical slot. And why not hatching lines on the trapezoidal plate? Because that is a rule in sectional views, that largest surface of the plate must not have hatching lines on it. So this is how we have completed the three views: sectional front view, top view and side view. And now dimensions as usual. So insert all given dimensions, taking care of all views of the dimensions. Before you insert dimensions, show the cutting line. This is the cutting line. End dash is dark. Remember what I told you? This is a rule in sectional view. Listen once again. When you draw sectional front view, cutting plane line must be one of the other two views. When it is sectional front view, cutting line must be either in the top view or in the side view. But really speaking, it is not either or. Listen. Show cutting line in that view in which less number of hidden details are. Show the cutting line in the view in which less number of hidden details are. And that is why we should prefer cutting line in the top view. So this is the cutting line in the top view. And this is the complete drawing. Insert all dimensions as usual. When it is portion of a circle radius, when it is full circle diameter, all given dimensions as usual you should insert. As far as possible, don't insert dimensions for hidden details. And that is why the hole in cylinder which is hidden here, or holes in the horizontal plate which are hidden in the side view, don't insert those dimensions here. You should prefer dimensions in the top view. Okay. Thank you for watching the video.